Starting from this video, we will shift our attention to plastic pipe. Actually, plastic is the latest entry into the material list for manufacturing pipe. Not originally thought of as a product capable of performing in the environs of a piping process facility, plastic has emerged as a reliable, safe, and cost-effective alternative material. There is actually a broad range of plastic compounds being developed today. For piping systems, two categories are most effective. These are fluoroplastics and thermoplastics. Fluoroplastics are found in materials like PTFE. As a group, fluoroplastics perform extremely well in aggressive chemical services at temperatures from -328 to 500 degrees Fahrenheit. On the other hand, thermoplastics are those plastics that require melting during the manufacturing process. This is the case of polyethylene or polypropylene. These plastics can be welded or injection molded into shapes for machining into piping system components. For some piping systems, it is now inconceivable not to use plastics. Pipes made from plastic are replacing traditional expensive materials like glass or ceramic-lined pipe. Actually, some plastics, such as polyethylene and nylon, have such excellent wear resistance that they prove in Tabor abrasion tests to be 5 to 10 times better in this regard than stainless steel. The Tabor abrasion test cycles an abrasive wheel over the face of a plate made of the material being tested, as depicted in this example. And after 1000 cycles of the wheel, the plate is measured to determine the amount of weight loss. The following table lists the results for various piping materials. Notice here that PVC and PP are way better than stainless steel. Plastic pipe can be joined by one of the following methods: threading, solvent cement, or fusion. Threading plastic pipe, as depicted here, is not a viable option because it is expensive. Heavy wall thicknesses are needed, and leaks from high pressures and expansion and contraction are difficult to control. Joints made with solvent cement have proven more reliable. Keep in mind, however, once hardened, cemented joints cannot be disassembled. They offer good resistance to abrasive chemical and high-pressure commodities and are available in a large selection of fittings without the need of threads. Finally, heat fusion must be performed on some plastic compounds that are resistant to chemical solvents. Now, plastic pipe can either be butt joined or socket joined. Heat fusion can be used with thinner wall thicknesses and are pressure resistant beyond the burst pressure of the pipe. Socket fittings provide large surface contact between the pipe and the fittings and are resistant to separation. For this reason, they cannot be disassembled. Although fabrication with plastic may sound simple, caution must be exercised when using plastic pipe. The effectiveness of a particular grade of plastic must be tested first before it is chosen for a particular service. In this regard, 4 important variables must be evaluated. These are chemical resistance, pressure limitations, temperature limitations, and stress. the various molecular components of plastics make them susceptible to chemical reactions with certain compounds. Hazardous mixtures must be avoided. Pressure and temperature limitations must be established for obvious reasons. Pipe that is overheated or pressurized beyond capacity can rupture, split, or burst. Stress as applied to plastic pipe entails physical demands such as length of service, resistance to expansion and contraction, and fluctuations in pressure and temperature. For this reason, excessive stresses in the form of restricted expansion and contraction and frequent or sudden changes in internal pressure and temperature must be avoided.